Thank you, everybody, for attending this talk series as part of the um, AI Industry Day. So we have three exciting speakers. Joel Blit, uh, who's a professor at the University of Waterloo, um, followed by Bart Pivovar, who is a VP at um, one of our partners, um, and Ashokan, who is also a professor in the computer science department. So allow me to start with Joel, and then I will hand it over to him, and then to Bart, and then to Ashokan. So once again, it's my great privilege to introduce Joel Blit. Joel Blit is a senior fellow at the CIGI Institute in Waterloo, as well as a professor at the University of Waterloo in economics. And he's an expert on the topic of innovation, focusing on Canada as a regional example for the global economy. He has expertise in economics of innovation, technology clusters, intellectual property, entrepreneurship, international trade, and multinational corporation. And he's also a very valued member of our AI Institute. So without further ado, Joel, the floor is yours. Thank you.
Thank you so much, Vijay. Thanks for the introduction. Okay, so let me share my screen. So everyone can see my my slideshow here, and everyone can hear me, I imagine?
I can definitely hear you, yes.
Okay, fantastic. Okay, so thank you very much. So I want to talk to you today about strategy in the age of digital disruption. So in other words, I want to talk about how businesses should think about artificial intelligence and about machine learning in particular, and how they should think about implementing it and the benefits that it might bring. So to give just a very quick overview of the talk today, I'm going to make the case that machine learning is little more than a better prediction technology. Now it's, I'm going to argue that fundamentally it's about a technology that can make better prediction. Of course, it's a little bit more than that, but that's sort of the crux of it. I'm then going to argue that prediction is everywhere. And then we're going to talk about, by the way, and because it's everywhere, then a better prediction technology can be very valuable. And that's why there's all this hype around machine learning. And it's not just hype, it really can change everything, as we're going to see. Now, in order to then embark on that discussion of what we would expect to see with machine learning in the future, it's always useful to go backwards in time and think about what other similar technologies have done. So we're going to do that. We're going to set the historical context. And then based on that historical context, I'm going to outline what I see as the three phases of technology adoption. And those three phases are going to directly feed into what I would argue is a logical process that businesses should follow for adopting machine learning. Okay, so that's basically a very quick outline of my talk today. And so I thought we would start with a thought experiment. So imagine that you have your own ice cream store, and you're trying to decide on inventory and staffing levels for the next 2 weeks. And the question is, what are you going to do? And so I would argue that if you want to figure out how much staff to have in for the next 2 weeks and how much inventory to keep or to order, you're going to want to try and predict ice cream consumption over the next 2 weeks. And in order to do that, well, what are you going to do? Well, the very first thing you'd want to do is to collect some data or go find some data on what factors influence ice cream consumption to then be able to make that prediction for ice cream consumption in the future. And so here on the right-hand side, you see that there's a very small data set. This is an actual data set that was collected in the 1950s in the United States on ice cream consumption. So the variable I see there, that is ice cream consumption per capita in that given month. Okay, so an observation is a month. And we also have what the price of ice cream was in that given month, what the income of individuals was, because you can imagine that ice cream is a rather frivolous thing. And so if you have high income, you can afford to spend it on ice cream. If you don't, you don't. And then, of course, the variable that we would expect to really matter is temperature. So if the average temperature over the last month was really high, we might expect there to be more ice cream sales. And so here is a plot of that data, right? So if we plot monthly consumption per capita against average temperature, we get that graph here on the right-hand side. And you can see that there is a fairly linear relationship. The higher the average temperature, the more ice cream consumption per capita in liters. And in the 1950s, when this data was collected, that probably would have been as good as you could have done in order to predict what ice cream consumption would have been. If you had been truly state-of-the-art, then you might have actually put in a best fit linear relationship through there. So this line that I just drew, which is fundamentally the same as running a univariate regression. And what that would have shown you is that for every additional 1 degree increase in temperature, the monthly consumption per capita would go up by 0.003. Okay, and so now you would be able to predict, based on what the weather forecast is for the next week or so, how much ice cream would be consumed. Now, let's fast forward to the 1980s. And so if you're now in the 1980s, you finally now have access to computers, and you could have computed a multivariate regression, and that would have given you a better prediction of how much ice cream was going to be consumed. Right now, what is a multivariate regression? It's just that instead of only looking at temperature to make the prediction, you also could have looked at the income of individuals and the price of the ice cream. Okay, and by the way, the price also could tell you how people are going to respond to a price increase, and so it can help you decide whether you should increase prices or not. Okay, and so now you have a slightly better model for predicting the future now that you have computers that can run these regressions. We can now fast forward again into today's era. And in today's era, you can use machine learning to make that same prediction. And so here on the right-hand side, I just have a drawing of a neural network with an input layer, a hidden layer, and an output layer. And fundamentally, if you haven't seen something like this before, all that matters is you feed into it the different variables. So for example, temperature, income, and price. And the model is going to predict what ice cream consumption is going to be. And so why is this an advantage over the previous technology? Because these models are a lot more complex, and they allow more complex nonlinear relationships between the variables for each variable. And they also allow interactions between the variables. So for example, any of these variables could matter, maybe not in a linear way, but it might be the square of temperature that matters. Or it might be that what really matters is the interaction of two of these variables. So for example, you might need high temperatures and high incomes together in order to sell more ice cream. Okay, the other nice thing about these models is that they require fewer assumptions on the structure of the relationship. And of course, everything has an advantage, also has a disadvantage. And the disadvantages of machine learning are, one, that it's a black box to a large extent, so explainability is often an issue. You might get a really good prediction of what ice cream consumption is going to be, but you won't know why that's the prediction. You won't know what's driving that prediction. And secondly, if the goal is prediction, that's great, but most machine learning approaches don't address causality, which is often something that we really care about, so inference. So fundamentally, you should think of machine learning as another step, and a very important step, of course, along the along the path of making better prediction. So fundamentally, and that's the point made in this book here on the bottom right, machine learning is nothing more than a better prediction technology. But the point is that because it's so much better than previous technologies, it results in entirely new applications and opportunities. And we're going to talk about those later. So let me just give you some examples of where prediction happens in the real world, where machine learning is used for prediction. So one of these is in speech recognition. So for example, so what is speech recognition, right? So someone speaks, those sound waves are converted into an electronic signal. That electronic signal is sent to a computer, and the computer is trying to predict what words are being spoken, right? So that electronic signal, what words do they represent? That's speech recognition. So it's fundamentally a prediction exercise. Similarly, natural language processing is trying to predict, among other things, which two words have a similar meaning, right? So it might be a text and you're trying to figure out, well, what does that word mean Does it, what other words have similar meaning? Or in some of my own work, for example, I'm trying to determine which documents contain similar ideas. So I look at patents, for example, and I'm trying to figure out which patents contain a similar kind of innovation. On the top right here, we have recommender systems. This is what Amazon does, for example. So they know that if Joanne likes book A and book B, she's probably also going to like book D. On the bottom left, we have computer vision. And this, again, is just trying to predict whether that object over there is a car or maybe it's a bicycle. Again, it's a prediction problem. In the middle, on the bottom, we've got autonomous vehicles. Autonomous vehicles are trying to predict what different objects are. So again, computer vision. They're also trying to predict where objects are located in space and how they're going to move in that space, right, over time. And lastly, on the bottom right, we have drug discovery. And drug discovery fundamentally is trying to predict what molecules and what compounds are going to be able to address different diseases. So all of these very common applications of machine learning, fundamentally at the core, are about making better predictions in different domains, in different areas. Now, I've hopefully convinced you that, especially for those of you that maybe are less familiar with machine learning at this point, one way that you can think about machine learning is that it's just a better prediction technology. And now the next thing I want to convince you of is that prediction is everywhere. And because prediction is everywhere, the benefits of better prediction, of machine learning, are very large. And so let's just look at a few examples. So imagine that you're a retailer. Many of you were probably at the keynote talk. And so Loblaws is such a retailer. And if you're a retailer, you might want to be doing things like predicting sales in order to manage inventories, much like the ice cream example that we just saw. You might also want to be predicting the impact of prices on sales so that you can better maximize profits. If you increase prices by a certain amount, you want to predict how much fewer goods you're going to be selling, and that information, that prediction, is going to allow you to set optimal prices. You might want to predict the impact of product placement on sales. So by predicting how sales are going to respond to placing different products on different shelves, you're going to be able to decide where to place your products. You might want to predict the impact of advertising on sales to drive your marketing campaign. You might want to predict the performance of future employees during hiring. So when you're hiring, you're trying to figure out who's going to be the better employee. You're trying to predict their performance. That's what you're fundamentally doing based on their CV and the interview. You might want to predict currency fluctuations that can impact supplier prices, et cetera, et cetera. If you're a retail bank, again, I can come up with a similarly long list. This is an area where I worked before as a consultant. If you're a bank, you might want to predict default. That's kind of the obvious one. If you're ever going to be making a loan to anyone, you're going to want to know what are the odds that you're going to be repaid, and therefore what is the interest rate that you should set, or whether maybe you should not make a loan at all. You want to be predicting fraud. So every time you see a transaction, whether it's on a credit card or on a checking account or anything like that, is it likely a fraudulent transaction or not? You want to predict the future value or profitability of a customer. This is maybe a little bit of a dirty secret in the industry, that the banks these days differentiate between all of their customers. They know exactly how much value different customers are bringing, and they're going to treat different customers differently based on how much they're worth. And not just how much they're worth today, but how much they'll be worth to the bank in the future. And so there's a prediction algorithm there as well. You're going to want to predict customer response to a bank action. So for example, if the customer writes a check and they don't have the funds to cover it, do you bounce the check or not? And you want to predict how the customer is going to react to that, and therefore what's the best course of action. You want to predict what other products a customer may want. So again, marketing. You might want to predict customer attrition to preemptively enact retention initiatives. And you might want to predict service times to better allocate staff to the different services. If you're an investment bank, again, we can think about predicting stock market fluctuations, the prices of an equity, interest rates, currency fluctuations, recessions, or interest in an IPO that you're underwriting. If you're a natural resources extraction company, you might want to predict the location of resources, the quantity of resources, the cost of extraction, the prices of natural resources, or maybe if you're building a mine, construction costs. And the last example, if you're a pharmaceutical firm, the obvious one is you want to predict which molecules may successfully target a disease, so basically drug discovery. But you also want to predict things like efficacy of a drug or a vaccine. You want to try and predict its side effects. You're going to want to predict flu strains if you're a manufacturer of vaccines, for example. If it is going to be, you're going to want to know which strains are likely to be most prevalent to include those in your vaccine. And lastly, you of course want to predict demand for a given drug to decide whether it's worth developing that drug or not. So there's just some, 5 examples of where prediction happens in 5 different industries, in 5 different types of firms. And hopefully what I've convinced you is that prediction is everywhere. And if you're running your own business, one of the things you should be thinking about is where am I doing prediction and where might I benefit from better prediction? Okay, I'm going to shift gears here just a little bit. And before we talk about how businesses should think about machine learning and the implementation of machine learning and machine learning strategy, I want to give a little bit of historical context, because understanding how other similar technologies have been adopted and what impact they've had is going to give us a really important window into what we should expect to see with machine learning and therefore into firm AI strategy. So here's just a slide explaining why it is that machine learning is now a practical solution to real-world problems. And by the way, the answer is not that we now have super fancy algorithms that we didn't have 20 years ago. That certainly is part of the explanation, but I would argue that it's not the biggest part of the explanation. So for example, neural networks have been around for decades. It's just that they weren't practical solutions to everyday problems because we didn't have the computational power or the data sets to actually take advantage of those technologies, so of those algorithms. And so what has really changed is the exponential growth in computing power. So basically Moore's law. And that's what I'm graphing here on the left-hand side. You can see that computing power has increased exponentially. And as a result, even if you compare it to a decade ago, the amount of computing power and the cost of computing power the cost is way lower, and there's much more of it to be had at a reasonable cost. As a result, you're able to run these machine learning algorithms that are very computationally intensive. Now, the second piece, of course, is digitization of processes. And this plays in 2 different ways. So machine learning is very data hungry. You can't estimate these really complex models unless you have lots of data. And the nice thing is that with digitization, as processes have become more and more digitized, more and more data is able to be collected. And so therefore, there's a lot more data to feed into these algorithms and better predictions can be made. The other reason why digitization matters is that digital systems are a better host for AI systems, for machine learning and other such things. So when it used to be that you used to go buy a book at your local bookstore, there was no place that you could embed a recommender system. Now that most of us buy the majority of our books online, it's easier to embed a recommender system because you're already in this digital medium. So that's the thing that has really changed. And given how much we're hearing about machine learning and about AI, surely there's been massive adoption, and surely we're seeing that in the productivity figures. And so that's what I'm plotting here on the left-hand side. And the short answer is, no, we're not seeing that. Okay, so as it turns out, productivity is in the 2010s, in the last decade, was the lowest that it's been, basically on record. And so how does this square with the fact that we all believe that machine learning and AI is this revolutionary technology that is changing everything? Well, the reason why it squares with that is that AI is a general purpose technology, and general purpose technologies take a really long time to be adopted and to have an impact. And we're going to delve into that a little bit further, but let me define what a general purpose technology is. A general purpose technology is a technology that first of all is pervasive. So it's not technology that is going to be applied in one sector, one area, one industry. It's a technology that's going to be applied broadly across many different areas and for many different purposes. That's the first part of the definition. The second part is it's a technology that's going to continue improving. So it's not a technology that has been developed and is now static. This is a technology, machine learning and AI, that is going to continue improving both with having bigger data sets, with having more computing power, and with having better algorithms. And thirdly, AI is going to spawn complementary innovations. And that one, as we're going to see a bit later, is absolutely key. So we can't even imagine yet the true impact of AI, because eventually AI is going to combine with other technologies to create entirely new things. So let's look at some of these other general purpose technologies, right? So what are they? It's things like the steam engine, it's things like computers, like ICT, things like electricity. And so let's start looking by Time Magazine's Man of the Year, which in this case happened to be the machine, which was the computer. And so in the 1970s and 1980s, we had the rapid development of IT technology. And the interesting thing is that this was accompanied by a productivity slowdown. And that actually led Robert Solow, who is a famous economist, to quip that you can see the computer age everywhere except in the productivity statistics. And of course, no sooner had he said that in 1987, that productivity began to surge, right? So that started happening in the 1990s. That's when these technologies really starting to make an impact on the world and on businesses. And so the question is, well, why is that? So initially, computers were just being used to replace humans in computational tasks. So for example, they were being used to replace bookkeepers and other such tasks. But in order to truly leverage the possibilities of computers, what you really had to do was you had to completely reimagine the way that you did business, your workflow, your operations. And so that's what gave rise to this whole idea of re-engineering the corporation, business process re-engineering. Okay, and so for example, if you read this book, you'd learn all about how Ford re-engineered all of their accounts payable in order to make them more accurate, faster, and cheaper. You would also learn about how Mutual Benefit Life used these technologies to completely change the way that they handled applications. And so instead of having 19 people in 5 departments handling each application, you now had one person handling it. And as a result, the process was cut down from somewhere between 5 to 25 days to as quick as 1 day and as long as 4 days. So a lot faster, more accurate, more responsive. That's where the true impacts of computers started to be felt. But of course, it's a lot broader than that. So computers also allowed firms to adopt more decentralized organizational structures. With computers, you could better maintain control of the organization, even if it was more decentralized. And so firms could change organizational structure and become more efficient in that way. You could also spread out geographically because these technologies allowed you to communicate better, right? So now you could communicate with someone halfway around the world. Potentially many of us on this call are not sitting anywhere near Waterloo, where I am now. It also allows you to connect with customers and suppliers globally and with unprecedented speed, and it allows you to collect and analyze massive amounts of data, which of course eventually led to what we have now, which is machine learning and other such technologies. So computers initially just replaced a few workers, made a few workers more efficient, but fundamentally they eventually allowed firms to completely change their operations, the way that they were organized. Let's look at another example, electricity. So electricity is another general purpose technology. Electric light generation dates back to at least 1808. That's when the first light that was electrically powered appeared. The electric motor and dynamo are from 1821 and 1831. The telegraph started in 1810 and then made many subsequent developments all the way up to 1851. And the first central generating station, so Edison Station, came online in 1881. Now, at that point, you could use electric lights, but if that's all that you used electricity for, you were really missing the real value of electricity. You were basically just scratching the surface. Instead, what ended up happening is that electricity completely changed the way that business was run, and specifically factory electrification over the 1890s to 1920s completely changed the reorganization of the factory floor. You no longer needed to have all the machines that required power all together in one area where the power source was. Now you could set up your factory all on one floor and in a more logical way so that the products, the intermediate products would flow logically from one station to the next. Basically, because you could now reorganize the factory floor, factories became much more efficient, and that was a really big impact of electrification, not the fact that we now had a better light, right? So that's why productivity really began surging in the 1990s, not in the late 1800s when we finally had electric lights. And of course, if you then fast forward some more, by the 1970s, we had silicon microprocessors. And so we now had that electricity was interacting with other technologies to create computers, which then themselves led to other things, as we just discussed. And so let me summarize what I see as the lessons from history. And the first is that the adoption of general purpose technologies takes a really long time, but eventually they're widely adopted and they change everything. Second, the full impact of general purpose technologies is not felt for a long time. And so because adoption takes a long time, the impact also takes a long time. And in my view, it roughly follows three phases. So adoption and therefore impact follows three phases. And so let me outline those phases. And I think this is a really important slide because this is what is then going to feed into helping us think about how technology should be adopted. So first, phase one is that new technology displaces old technology, often people, to increase the efficiency of existing processes. And so, for example, in the case of electricity, here we have that electricity is providing better lighting, and so you're displacing the old type of lighting. In the case of computers, you're displacing bookkeepers. This is going to increase efficiency, but it's fundamentally not going to have a huge impact. Phase two is where new technology allows the complete reorganization of processes. So again, changing the factory floor or computers allowing firms to completely reorganize their operations. And the last one is where new technologies combine with other technologies to create entirely new things. And this is sort of the blue sky one where it's hard to predict what's going to happen. And so taking those three phases, let's now talk about AI strategy. I'll quickly talk about opportunities and then even more quickly about risks. And so in terms of phase one, as I was mentioning earlier, is where you increase efficiencies. And so if you're a business, what you should do is you should break down the workflows into tasks, identify tasks that are fundamentally prediction, and then compute the ROI for automating each prediction task. So these are the tasks where you might be able to use machine learning to become more efficient. And then starting with the top of the ROI list, start replacing humans with machines. Start replacing whatever you're using for prediction before with machine learning, again, if it's feasible. Now that's going to get you part of the way there, and it's definitely worth doing. But where things are really going to change is in phase two. And by the way, most firms still don't have machine learning at all. The advanced firms are now in phase one, and the very cutting edge firms are perhaps in phase two. And so what's phase two? Well, this is where you leverage cheaper and more accurate prediction to reinvent the way you do business. And so I'm just going to give you a couple of examples here. Imagine that you're Loblaws and you got so good at predicting what customers wanted. What would you do with that prediction? Well, one thing you might want to do is you might completely reorganize your operations. Instead of having a physical brick and mortar store and waiting for people to walk into your store and buy the milk and whatever else they want, if you know what they're going to want ahead of time, you're just going to get a delivery truck that's going to drive around neighborhoods and it's going to drop off everything that people need when they need it at their door. As a result, you're going to refocus around supply chain management and on product delivery and reduce your physical presence. Imagine that you're a large bank. What if your prediction got so good that you knew who your most valuable customer would be and what they wanted before they did? Well, then you would have preemptive, pre-filled, pre-approved applications for new products and services. To a large extent, that's already happening, of course. Imagine last but not least that you're a large brick and mortar store, you're Barnes and Noble. What if your predictions of what book your customer wanted got so good that the customer no longer needs to look for books themselves? Well, you no longer are going to need physical books for browsing. You no longer need staff to offer advice and recommendations, and therefore you don't need your brick and mortar store. So what you would do is you'd become an online book retailer with a world-class recommender system, and you'd focus on complementary capabilities like fulfillment. Sound familiar? That's basically Amazon's model. Amazon basically figured this out early on, and that's why they're around and huge and successful, and Barnes & Noble is not. And lastly, phase three. So phase 3 is where the best advice is, we don't know what technologies are combined with each other, with prediction in particular, but you should be tracking different technologies and how they might combine with prediction to create new industries and opportunities. So what are those technologies? Things like robotics, 5G, Internet of Things, and 3D printing. And just to give you one example where I see a confluence really changing everything, I think robotics is combining with AI to allow robots to interact with people in everyday environments instead of being kept away from people in a factory in a corner of the floor. And that's just going to completely change what robots are going to do. And that's where we're going to see the true robotics revolution as a result of the confluence of AI and robotics. Other strategic considerations, very quickly again, how quickly to deploy AI. So the quicker you deploy it, the higher risk, but also the more learning you're going to do and the further along you'll be in that curve. What you should outsource versus keep in-house. And I think importantly, can you capture the value of AI or do others own complementary functions? So here's some really valuable advice by Hal Varian, who's the chief economist at Google. And he says, seek to be an indispensable complement to something that's getting cheap and plentiful. So in this case, what's getting cheap and plentiful is prediction. And so you should make sure that you own what is a complement to it. And so what's a complement to it? Well, one thing is judgment. It's knowing what to do with better predictions. When we had no predictions, it didn't matter if you were wise or not because there was nothing to apply that wisdom to. Now that we have predictions, knowing what to do with them becomes way more valuable. And lastly, you should be managing risk, right? So you need to manage the risk that's associated with the quality of your input data. You need to manage the risk in that the data that you're feeding back into your system could be being manipulated. There's a lot of talk around bias and discrimination, again, very important. And also really important from a strategic point of view is disruption by AI-first startups or by competitors that are adopting these technologies. Okay, so better prediction poses opportunities, but also risk to established firms. Others are also going to be implementing AI and becoming more efficient, and they're also going to be reimagining the way that they do their business. And so let me conclude. I think we're on the cusp of a technological revolution led by AI. As a matter of fact, I've written extensively on the fact that this pandemic has accelerated that revolution. You should think of machine learning to a first degree as a better prediction technology. And therefore, you should think about how better prediction technology can help your business. And in this regard, there are 3 phases. First, identify where you have prediction tasks in your business and consider deploying machine learning. Then start to reimagine how you can, you can reinvent your business with this better prediction technology. And lastly, keep a lookout for complementary technologies. And to conclude, you really should be trying to move fast because if you don't, you can be sure that others will. So thank you very much. I think I might have gone a little over, so I don't know if we have any time for questions, but I'm going to stop there. Thank you very much.
Thank you, Joe, for a fantastic talk. We have time for 1 or 2 questions. If there are any questions, please do type in the Q&A chat. If not, let me ask a question. So you mentioned some risks if you go back 1 slide. And coming from a security perspective, I always think of risk first. So in particular, with regard to these issues with bias and discrimination, on the one hand, and also, as you well know, European Union has the GDPR law, for example, and there are other laws that are coming on board to from a privacy perspective, from a security perspective. So do you have any insights into how companies can minimize their risk with respect to these laws as they deploy these machine learning models? Have you considered that question?
Yeah, I think like any other technology, early on it was everyone was rushing in. There was very little regulation. I think regulation is slowly starting to catch up, and of course the Europeans are leading the way in that regard. And so I think if you had moved 10 years ago, you probably didn't have to worry about any of this stuff. It was a little bit the Wild West. And nowadays, of course, you're going to have to worry about that when you collect data from customers. You have to worry about privacy and all of these other requirements. You're going to have to keep an eye out as to what the standard is going to be, because of course Canada has different standards than the European Union, different standards than the US, and it's not clear that they're all going to merge. So I guess I don't have a great answer. It is complicated. It's not going to be easy to manage that. And so I think, I would reach out to the government of Canada. I would reach out to experts that can help me navigate that increasingly complex landscape of regulation that is also changing continuously.
There are a couple of questions. Thank you for your session. You mentioned many things about prediction, but what about other aspects of AI? Reinforcement learning, for example. Where do you see the place for RL in the future?
Reinforcement learning. I guess I don't know enough about reinforcement learning to see how it fits in.
Yeah, I can very quickly answer. A great question, by the way. There is going to be some talks on reinforcement learning in one of the other sessions, but briefly, reinforcement learning is a little bit different from kind of neural network based predictions, although there are combinations of the two, deep RO, for example. And a lot of the work in reinforcement learning is focused on either game playing or focused on more like control systems. That's where it seems to be. Also, in some cases, in the prediction of like stock market and so on. But it's a little bit different compared to the totally data-driven DNN based predictions. Another question is, any recommended strategy to change the culture of employees of using predictive models? Some feel threatened, for example, salespeople, that their jobs will be lost. So very quickly, Joe.
Yeah, so look, that's a great question, and I give a similar talk. So I've given entire talks on that issue, and unfortunately, I can't answer in 2 minutes. But look, I am really concerned about the impact that AI and machine learning is going to have on jobs, first of all, and secondly on inequality. Again, that is my number one concern. And if you had been here last year, that would have been my talk. I've written on that. If you want, you can search it up. I think fundamentally it's a policy issue where we're going to have to realize that they're going to have an impact on the workplace, on the future of jobs. Some people are going to fall through the cracks, and we have to worry about retraining. That's the first piece. We have to worry about making sure we have solid safety nets, and also about broad taxation, because there's going to be huge winners from these technologies as well as losers. And so that's a fantastic question, and I would love to spend another hour talking about it.
Thank you, Joel. We'll definitely invite you again for a talk on that topic. Thank you again. This was fantastic.